Alright, so here in this one, what we're going to do is we're going to prove that a linear combination of linear combinations is again a linear combination. And obviously the key thing here is that we need to understand what a linear combination even is. So if we have like c1 x1 plus dot 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 going down cn xn, we say that this here is a linear combination of the variables x1 through xn. Now we want to show that if we have a set or whatever, just a bunch of linear combinations, right? Say like c1 1 x1 plus, c1 2 x2 plus dot 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 going down c1 n x sub n, right? That's one linear combination. Then you could take another row. This is another linear combination of, again, the variables x1 through xn. So you could do dot 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 going down c2 n x sub n, and then you could go down to whatever cm1 x1 plus dot 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 plus cm n x sub n, right? And here you have you have a bunch of linear combinations. Now a linear combination of these linear combinations then would look like something like this, like d1 and then this entire linear combination, right? c1 1 x sub 1 plus dot dot dot, and you want to skip over as much as you can at this point because it's going to get tedious a little bit, plus d2, right? And then you can do this, right? And again, the c11, these here, right, everything, all the coefficients are just real numbers, right? It's only the x1 through xn that are variables. And then you have c2 1 x1, right? And again, these are just real numbers, the c2 1, these coefficients. And then d1 is also just a real number, d2 is just a real number, and then you have c2 1 x1 plus dot 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 c2 n x sub n plus dot dot dot. You go all the way down to some dm cm1 x1 plus dot 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 cm comma n x sub n. And what I'm going to show is that this is just going to be a linear combination of the original x1 of the original variables, because you see you distribute the d1 everywhere into here and you're going to get d1 c11 x1, right? Plus, now if you look, when you distribute the d2 here, you're going to still get a d2, right, within x1. So what happens is that ultimately the x1 will factor out, right? Or the x1 will factor, and you'll have an x1 here. And then on the inside, what are you going to have? You're going to have d1 c11 plus d2 c21, right? Plus dot dot dot. Going down, you should see, right, dm cm1, right? And then that closes off the parentheses here, x1 plus dot dot dot. And then again, you do this for all of them, and you should see that this is going to be a linear combination of x1 through xn. I mean, like, you could see for x2 and just play this game again, but at the end of the day, it'll be a linear combination of the x1 through xn. Again, I mean, a big deal would be to see that this here is also just another real number, right? Again, d1 is some real number, c11 is some real number, d2 is a real number. So this is just the sum of real numbers, which is just a real number. So this is just a new coefficient, whatever, I don't know, k1, right? And then again, you get a linear combination of the original variables x1 through xn.